Yes, Lena. So, yeah, we were discussing binomial expansion and today we are going to finish that. Okay?
Okay, ma'am.
Okay, let's start the discussion. Can you see the screen?
Yes, ma'am.
Okay. So, previous day we were discussing about the general term and the middle term, right? And I said to you that general term we will be writing r plus 1th term can be written as NCR x to the power n minus r y to the power r, right?
Yes, ma'am.
Because we realize that first term is NC0, second term the coefficient is NC1, third term the coefficient is NC2. So one less is there. That's why r plus 1th term will be NCR, right?
Yes, ma'am.
So that was the general term. And we were also discussing about the middle term, that if n is an even number, then there is only one middle term. Why? Because if n is an even number, for when we are having power 2, then we were getting 3 terms. When we were having power 4, then we were getting 5 terms. So one more term we were getting always. So that's why we are saying that when n is even, eventually the number of term will be odd, and that's why there will be one middle term, that is this one. And when n is odd, n means the power is odd, we will be getting two middle terms. Okay. Now let's solve few questions related to this concept. One more thing we will be discussing over here. Just a moment. That if you will see, the expansion of let's say x a plus b whole square. So that is a square plus twice ab plus b square, right?
Yes, ma'am.
Similarly, if we are having a plus b whole cube, then the expansion will be a cube plus 3a square b plus 3ab square plus b cube, right?
Yes, ma'am.
So what are we noticing over here? That whenever this type of expansion is there, a plus b whole square, here the coefficient of the middle term is the greatest, right? This is the middle term's coefficient is the is the largest number. Like we are having the coefficient of the first term, coefficient of the second term, coefficient of the third term, but middle term is having the greatest coefficient. Can you see?
Yes, ma'am.
Here also for the other one, since the power is odd number, now only we are saying when it's odd there will be two middle term. So you can see two middle term over here, and both the coefficient are the greatest only, right? Right.
Yes, ma'am.
So we can conclude from here that the middle term is having the greatest coefficient. Okay. Now when we will be having question like this, when the question says the greatest coefficient in the expansion of 1 plus x to the power 2n is, so here we can say since 2n is a even number, right? It's an even number. The power is even. Can we say?
Yes, ma'am.
So here the power is even, and the power, when the power is even, there is only one middle term, that is n by 2 plus 1, right? So n by 2 plus 1th term is the middle term when the power is even number. So here our n is 2n. So we will be saying here the middle term will be 2n by 2 plus 1. That term will be the middle term. That means n plus 1th term will be the middle term. What exactly the question says? The question says the greatest coefficient. Now only we have realized and we have figured it out that the middle term is having the greatest coefficient, right?
Yes, ma'am.
That's why we, just after looking at the question, we started finding the middle term. Which term is having the greatest coefficient? Middle term will be having the greatest coefficient in general. Exception we will be discussing after a while, but the greatest coefficient is like the middle term is having the greatest coefficient. So according to that, we started finding the middle term of this one, and we realized we have to find n plus 1th term. That will be the middle term, and that coefficient will be the greatest coefficient. That will give the greatest coefficient, right? Are you understanding the concept?
Yes, ma'am.
So we can say which term? So term n plus 1th term will give the greatest coefficient. That will be, what will be that coefficient? The coefficient will be like, there is a formula for general term. R plus 1th term formula is NCR, x to the power n minus r, y to the power r. When the expansion we were doing for x plus y to the power n, this one's expansion, rth term was this one. Similarly, we are here doing the expansion of 1 plus x to the power 2n, and that's n plus 1th term we have to find. That is the middle term whose coefficient is the greatest one. So n plus 1th term will be NCR. This is our R. This is our N. Okay, this is not R, this is R plus 1. Okay, this is R plus 1. This is N. So let's use this formula. So it says general term, that means R plus 1th term will be NCR. So N is 2N. C R. R is only N, can I say?
Yes, ma'am.
Now the first term, that is 1 to the power 2n minus 1, 2n minus n, and the next term, that is x to the power only n. Okay, is it clear?
Yes, ma'am.
So here we wanted to find the greatest coefficient only. Coefficient means whatever is there in front of x, that everything is coefficient. When it is asking about the binomial coefficient, we will be taking only this one. When it is asking the coefficient, leaving x and y, whatever is there, everything is coefficient. This all are coefficient. When it is asking about the term, what is the term? So this total is the term. That is the difference between binomial coefficient and the term. Term means everything, your r plus 1th term, whatever you have got, x, y, everything is there in the term. Okay, binomial coefficient means only NCR you have to take. Coefficient means if any number is having power, any extra number is there apart from variables and all, everything you have to take as a coefficient. Suppose I am writing x square y cube, 3x square y cube. Here the coefficient of x square y cube is 3. Okay. Now if I am writing NC, let's say I'm going to write over here, one of the term is 5c3. times this one. Here, which one is the binomial coefficient? Only this one is the binomial coefficient. Which one is the coefficient? Everything is the coefficient. What is the term? This total is the term. Getting?
Yes, ma'am.
So this is how we will just identify the particular word and we will be going ahead accordingly. Here, let me take the other question. Is it clear?
Yes, ma'am.
So the first question was, if n is even, then the middle term in the expansion of x plus a to the power n is a t n by 2, b t n by 2 plus 1, c t of n by 2 minus 1, and d t of n by 2 plus 2. Can you tell me which one is the correct option? N is even. When it's even, then how we will find the middle term? Can you see this rule?
Yes, ma'am.
So which one is the correct option? This one, right?
Uh,
Which
B.
one? B, right? This one. Because when n is even, this is the formula for finding the middle term. Like there will be only one middle term, that is n by 2 plus 1th term. And t of n by 2 plus 1 is representing n by 2 plus 1th term only, right?
Yes,
Let's
ma'am.
take the next question. The greatest coefficient, okay, which we did just now. Coefficient in the expansion of 1 plus x to the power 2n is 2n cn minus 1. This is the assertion, and the reason is the greatest coefficient in the expansion of 1 plus x to the power 2n is the coefficient of middle term. Now only we have discussed this concept. Can you please tell me which assertion is right, reason is right, both are right, both are wrong? What is the case? Let's read the reasoning part first, okay? And tell me whether it is correct or not. Is the
It is
coefficient of
correct.
middle term. Is it correct?
Yes, ma'am.
It's correct. Okay. What about the assertion? When this is the case, when the power is this one, what will be the middle term? If you are saying the reason is correct, that means you have to find the middle term, right?
Yes, ma'am.
Now only we have found, no, we have seen the formula for middle term. Can you tell me what was the formula? When n is even, the middle term will be n by 2 plus 1, right? Right,
Yes, ma'am.
Lena?
Yes, ma'am.
So here it's even. So now only we have done, the middle term will be 2n by 2 plus 1, right? That is n by 2 plus 1, right? This will be the middle term,
Yes,
right?
ma'am.
That means it will be term n plus 1, right?
Yes, ma'am.
And the general form of r plus 1th term, we know r plus 1th term looks like ncr x to the power n minus r y to the power r. So here n plus 1th term will be whatever is the power 2n c n, right? Is it correct?
No, ma'am.
So it's false. Okay. And this is true. Got it? Got it, Lita?
Yes, ma'am.
Let's move ahead. If the middle term in the expansion of x square plus 1 by x to the power n is 924 x to the power 6, then n is equals to, options are 10, 12, 14, 11. Which option is the correct option? If the middle term in the expansion of this is this, it's talking about one middle term. So what can be taken?
N by 2 plus 1.
N by 2 plus 1. So n by 2 plus 1th term is the middle term, and that will be n c n by 2, right? And cr
Yes, ma'am.
x to the power, our x is x square to the power n by 2 minus n by 2. Okay, n minus n by 2 is only n by 2, right? Right? N minus n by 2 is n by 2 only, right? 1 minus 1 by 2
Yes,
will
ma'am.
be 1 by 2, right? So we can also write it directly. And what else? 1 by x to the power n by 2. This is what we will be getting from here as a middle term, right?
Yes, ma'am.
Let's simplify x. So we will be having x to the power n over here. We will be having 1 by x to the power n by 2 over here. X to the power n minus n by 2. Can I write this total?
Yes, ma'am.
That is x to the power only n by 2. You must be thinking why we are not writing the first term. We will be having the first term. Okay, let's write it as it is for a while. This is what we got as a middle term. But the question says the middle term is 924 x to the power 6. So this, whatever will be the value of this, there is a x to the power 6 beside that. That means our x to the power whatever is there, that must be equals to x to the power 6, right? X to the
Yes, ma'am.
power n by 2 we have got, but the question says the middle term is having x to the power 6. Can we compare it like this?
Yes, ma'am.
So from here, can we say n by 2 is equals to 6 by comparing both the powers? N
Yes,
is
ma'am.
equals to 12. We don't even have to solve the coefficient. If you will go and try solving the coefficient, it will take a lot of time and you will not be able to find the value from here. Okay. So better to solve this power of x. Compare the power of x here. It says the middle term is having x to the power 6. We have got the middle term and that is having x to the power n by 2. So we can say x to the power n by 2 is equals to x to the power 6. From there we got n is 12. What the question is asking, then n is, we can say then n is 12. Clear?
Yes, ma'am.
So always look for the easier way to simplify the things. Now the next question says, what is the sum of, what is the sum of coefficients of middle term in binomial expansion x plus 2y to the power 9. We are not going to solve it because you will be able to do it. Here the power is odd. When the power is odd, I have told you there will be two middle terms and those two will be, first is n plus 1 by 2. Okay, it's not n by 2 plus 1. It's n plus 1 by 2. And the next one, that is n plus 1 by 2 plus 1. Okay, when the power is odd number. Is it the power odd over here? Yeah. So the first middle term will be n plus 1 by 2th term. And the second middle term will be n plus 1 by 2 plus 1th term. Clear?
Yes, ma'am.
So the term will be 10 by 2, that means fifth term and sixth term. We have to write the fifth term from here and the sixth term from here. How? By using the general term formula. Again, I am reminding you, the general term r plus 1th term was ncr x to the power n minus r y to the power r. Similarly, fifth term over here will be, can you please tell me quickly what will be the fifth term if this is the binomial expansion we are having? 9c,
9, the 3,
yeah, will it be 5 or 4? R plus 1th term is NCR. Can you see?
yes, ma'am.
So fifth term will be NC4, 9C4, right?
Yes, ma'am.
After that, first term, whatever is our first term, that is 9 minus 4. Whatever is our second term, that is only 4. That first and second term, like after, first we have to write the binomial coefficient. Once we will be able to write the binomial coefficient, then we can write after that, that n minus r, then only r. That we will be able to do it, right? What will be the sixth
Yes,
term?
ma'am.
Yeah, what will be the sixth term if we are having x plus 2y to the power 9? Then its sixth term will be n is 9, c, r.
Okay.
If we have to find the sixth term, we will be taking one less, right?
Yes, ma'am.
Then our first term, that is x to the power 9 minus 5. Then our second term, 2y to the power only 5. Are you getting it?
Yes, ma'am.
Okay, from where are we getting this? Okay, previous day we have done the discussion about general term, that when we are having, let's say, x plus y to the power n, the formula was and C0, x to the power n minus 0, y to the power 0, right, Lina?
Yes,
Plus
ma'am.
nc1 x to the power n minus 1 y to the power only 1 plus nc2 x to the power n minus 2 y to the power only 2 plus nc3 x to the power n minus 3 y to the power only 3. Like that it will keep on going, right? So we realize
Yes,
that
ma'am.
our first term is having NC0. Can you see it?
Yes, ma'am.
Our second term is having NC1, the coefficient, binomial coefficient. After that, we will be able to write it. Once you are writing NC0, after that, even if you don't know anything, you will be saying first, whatever is the first term, be it x, be it y, be it a, that is power n minus 0, and whatever is the second term, if it is y minus 1, whatever is there, that to the power only 0, right? So you just need
Yes,
to
ma'am.
understand that what will be there as a binomial coefficient. And then rest of the thing, you will be able to figure it out, right? According to the binomial coefficient. Right, Lina?
Yes, ma'am.
So here, what are we realizing? We are realizing that first term is NC0. Binomial coefficient of the first term is NC0. Second term binomial coefficient is NC1. Third term binomial coefficient is NC2. Fourth term binomial coefficient is NC3. So R plus 1th term binomial coefficient will be NCR, right? One less. Yes or no?
Yes, ma'am.
Then if we are having x plus y to the power n, then x to the power n minus r, y to the power only r. This is the formula which we realized after seeing the binomial expansion. Now if I am going to give you that, if you are having a binomial expansion as a 1 plus 2x to the power 2n, okay, or we are saying let's rather than 2n, let's start with the number 9, and I am telling you find fifth term, fifth term, find it. Then how you will find? You will use the above formula, NCR. Okay, R has to be less than this one, right? One less than this one. So fifth term will be having coefficient NC 9C4. Are you getting it?
Yes, ma'am.
Now, your first term, that is 1 to the power 9 minus 4. Your second term, that is 2x to the power only 4. Getting?
Yes, ma'am.
Similarly, if I will tell you, write the sixth term, Lena, of this binomial expansion, directly write the sixth term. Sixth term, you don't have to expand it. Directly, we need the sixth term. So you will be saying, okay, the sixth term will be 9c. 6 means 1 less we will be having. And now the first term, that is 1 to the power 9 minus 5. Another term, 2x to the power only 5. Clear?
Yes, ma'am.
So this is how we are using the formula over here. Now, if you are having x plus 2y to the power 9, then what are the middle term? The middle term, since the power is odd, there will be two middle term. The first will be t, the formula is n plus 1 by 2. Okay, n plus 1 by 2. The other formula is t of n plus 1 by 2 plus 1th term. So that means t of 9 plus 1 by 2. That means t of 9 plus 1 by 2 plus 1. So from here we are getting t of 9 plus 1, 10 by 2, that means t5. And here we are getting t6. We have to find t5, we have to find t6 of term 5 and term 6 of this binomial expansion. Now only we have learned the general formula, which says that t5 will be NC r plus 1 if there, then r we will be taking over here. So that's why we were taking 4. Is it clearly now?
Yes, ma'am.
X to the power 9 minus 4 to y to the power only 4. Now sixth term will be, can you please tell me quickly now?
9c5 uh, x 9 minus 5 2y 5.
Yeah. If I am telling seventh term will be
9c6 x 9 minus 6 2y 6.
this is how we will be finding any term, whatever is asked by r plus 1th term formula. Okay. Now it says the middle term in the expansion of 2 by 3 x minus 3 by 2x to the power 20. Here the power is odd or even? Is it odd or even?
Even.
Even, then the middle term will be t of n by 2 plus 1, right?
Yes, ma'am.
That means t of 20 by 2 plus 1. That means t of 11. And now you know how to find t11, right? That will be, can you please
Yes,
tell
ma'am.
me what will be t11 quickly?
20c10 uh, 2 by 3x 20 minus 10 and minus 3 by 2x 10.
Perfect. This is how we will be solving the questions. Okay. Yeah, we are done. Whenever it says, just see the words properly. Just be careful with the wording. That is, whenever it says binomial coefficient, please, what will be the binomial coefficient? Your answer will be only this much. Okay, what will be the coefficient? That means you will be taking this number also, this number also with the power. And what will be the term? That means you will be saying everything. This all together are the term, 11th term. Okay. Now let's move ahead. Okay. If we have to find the particular term, then how we will be doing so? Just a moment. Yeah. So here the question says the term, we are just going to take the questions directly because the formulas which you have learned just now, which we were applying just now, that we will be using it over here as well. So the question says the term independent of x in the expansion of root x by 3 plus 3 by 2x square to the power 10 will be. Which term will be independent of x? That means there will be no x. Okay, or the power of x will be 0. So option A is 3 by 2, B is 5 by 2, C is 5 by 4, and D is none of this. The term independent of x. How we will be finding that? So here we don't know which term will be independent of x. But once we will do the binomial expansion of this 10, as you can see, maybe x and x will cancel out each other and maybe there will be no x in any of the term. It can be the case. But which term will be that? That we don't know. For that, are we going to expand it completely? No. We are not going to expand it completely. What we will be saying? We will be saying, let's say r plus 1th term is independent of x. Let's say r plus 1th term is such a term in this binomial expansion where x is not there. Okay. So r plus 1th term formula now only we have figured it out, that is NCR. So n is 10, C, R. Okay, R we don't know, still we don't know. First term, that is root x by 3, that to the power 10 minus r, that was the formula, n minus r. And the other term, that is 3 by 2x square, that power r only. Is it clear so far?
Yes, ma'am.
So it's saying which term is independent of x. That means which term is not having x. We are saying we don't know which term is not having x. Let's say r plus 1th term is not having x. Okay. Now what we will be doing here, we will be just keeping it 10 CR as it is. Here the power of x will be, we are just going to focus on the power of x. And then we will say the power of x is equals to 0. And we will try to find the value of r from them. So the power of x over here will be x to the power 1 by 2, and then power 10 minus r is there. Whatever is in denominator, it's there. Here 3 by 2 is there. It's okay. It will take power r. But 1 by x to the power 2r will be there. Right? I'm just focusing on x power. Is it okay, Lina?
Yes, ma'am.
Is it okay? This two only we will be seeing, and at last we will be saying, since it is independent of x, that means power of x is 0. So x to the power 10 minus r by 2, and here we are having x to the power minus 2r. So we can write both of them together, x to the power 10 minus r by 2 minus 2r. Is it okay? X to the power m
Yes,
into
ma'am.
x to the power n is equals to x to the power m plus n we have done. Now, since it is independent of x, we said that r plus 1th term is independent of x. That means there is no x over here. That means whatever x power we have got, x to the power 10 minus r by 2 minus 2r, this must be equals to x to the power 0. Right?
Yes, ma'am.
That means 10 minus r by 2 minus 2r is equals to 0. Let's solve it. 10 minus r by 2 is equals to 2r. 10 minus r is equals to 4r. That means 5r is equals to 10. R value we got 10 by 5. That means 2. What we needed to find over here, let's see. The term independent of x in the expansion of this will be. So we got r value as a 2. Which term is this? Which term is this? R plus 1th term, right? We have
Yes, ma'am.
assumed that R plus 1th term is such a term where the x is not there. So the term independent of x in the expansion of this. So R plus 1th term, that is R value we have got as a 2. So we will be saying 2 plus 1, that is third term from there. Which option is the correct option? None of these option is the correct option. Got it?
Yes, ma'am.
So this is how we will be solving the equations. Okay. Similarly, whenever it says to find, let me take few more questions from this concept, then we will be moving ahead. So here one of the questions is the coefficient of x to the power 39 in the expansion of x to the power 4 minus 1 by x cube to the power 15 is. So the coefficient of x to the power 39 in this expansion is. So we are having x to the power 4 minus 1 by x cube to the power 15. Now, when we will be having x to the power 39 after doing the whole expansion, are we going to see that? Like, are we going to just figure it out after doing the whole expansion? No, we will be saying, let's say r plus 1th term is having x to the power 39. Okay, is it okay, Lina?
Yes, ma'am.
So r plus 1th term will be NCR, that is 15 CR, x to the power n minus r, x to the power 4 to the power 15 minus r, y to the power only r, minus 1 by x cube, that is power only r. Is it clear so far?
Yes, ma'am.
Here, just leave 15 CR as it is. Here we will be having x to the power 15 4 times 60 minus 4r. Here we will be having minus 1 to the power r divided by x to the power 3r. This x to the power 3r will come in the numerator and we will be having x to the power 60 minus 4r minus 3r. Getting it? Minus 1 to the power r is there and 15 CR is there. Is it okay? This much?
Yes,
So
ma'am.
we will be having x to the power 60 minus 7r. But we are saying that r plus 1th term is having x to the power 39. So whatever our x to the power is there, that has to be x to the power 39. This x to the power 60 minus 7r must be equals to x to the power 39. On the basis of this assumption only, we have taken that r plus 1th term is having x to the power 39. That's why we are comparing it. Are you getting it?
Yes, ma'am.
So 60 minus 7r is equals to 39. Now from here r value we will be finding, that is 60 minus 39 is equals to 7r. What we'll be getting from here, 21 is equals to 7r. So r is equals to 3, right? Now what the
Yes, ma'am.
question says, the coefficient of x to the power 39. It's asking about the coefficient and I told you whenever it says coefficient you have to take everything whatever is multiplied with x. So we are going to take this one also and this one also. Can you see it? These are the coefficient of x to the power 39, right?
Yes, ma'am.
So it r value we just only we got 3. So the coefficient will be 15C3 and here minus 1 to the power 3, which will come as a negative 1 only. And this 15C3, we know how to do the calculation. 15 factorial by 15 minus 3 factorial into 3 factorial. This will give us the coefficient. Getting it?
Yes, ma'am.
So this is how we will be solving the question. Whenever suddenly, all of sudden it says x to the independent of x to the power 40, x to the power 39. So always you have to take the help of the general term. Let's say r plus 1th term is having this term. And then you have to simplify it. And then whatever is the power of x, that you have to compare it according to your assumption. So we are done with this concept also. Let's move ahead with the next concept. Numerically greatest term or coefficient. Just now we said and we have discussed that the middle term is having the greatest coefficient, right?
Yes,
Right,
ma'am.
Lena? But when the expansion is, let's say, 1 plus x square, here you will be having a square, 2ab, b square. Here you can see the middle term is having the greatest coefficient. But what about if you are having the expansion like this? Then what will be the expansion? A square, 2ab, b square. Can you see middle term is not having the greatest coefficient? Can you see?
Yes, ma'am.
For such scenario, we are going to discuss this concept, numerically greatest coefficient. It will not be the middle term when we are having such expansion. Okay. Here we are talking about numerically greatest coefficient. So which term is having the numerically greatest coefficient? Minus negative 36 is bigger or 28 is bigger. So numerically means modulus you have to put and you will be saying this is bigger. Otherwise, algebraically or just with the concept of integers and everything, that algebraically we can say minus 36 or 28, which one is bigger? This one is bigger. So numerically, whenever this word is there, that means which value is bigger. Forget about the sign. Okay. So this is the meaning of numerically greatest coefficient. Now we are saying here two cases we will be getting. One of the cases one of the cases, let's say there is a r plus 1th term that is having the largest, that is having the greatest coefficient. So this will be greater or equals to its previous term, that is rth term, and this r plus 1th term will also be greater or equals to r plus 2th term. Actually, binomial coefficient just go increase or decrease in a pattern. So we are saying that if there is a r plus 1th term, so it is bigger than this one also, and it is bigger than its next term also. Okay, this is the biggest term. That's why this is the term which is having the largest or the greatest coefficient. So it is having the greatest coefficient from its previous term also and from the next term also. Like from all the term it is having, but we are just taking two consecutive term and we are saying this and this, case 1 and case 2. Are you getting it?
Yes, ma'am.
Now from case 1 and case 2, there is a whole lot of deductions and all. I am going to write the formula directly. So once you will be taking TR at R plus 1th term, then TRth term, and then you will solve this inequality. You will be getting that n plus 1 by 1 plus mod of x by y. Again, whenever I am saying x by y, x means the first term, y means the second term in our binomial expansion. Okay, is greater or equals to r. This is one of the condition we will be getting one after solving this. Okay, you don't need to solve it. You need to keep this in mind. This one you need to keep in mind. The other one we will be having r r is greater or equals to n plus 1 by 1 plus mod of x by y minus 1. And when we will be taking case 1 and case 2, equation 1 and equation 2, when we will combine them together, let's say this is m. So r is less or equals to m. And let's say this is m. This total is m. I am saying that this yellow part is m. Here also you can see the same yellow part is there. So we can write it as r is greater than or equals to m minus 1. Okay. If you want, you can write these two relations. From here, numerically greatest term or coefficient and then this one. Please write it. Combining equation 1 and 2, we can say r is greater or equals to m minus 1, less or equals to m. This is the relation we have got. Rather than every time writing n plus 1 by 1 plus mod x by y, n plus 1 by 1 plus mod x by y, we are giving it a name, m. Okay? But we must know what is m. M means n plus 1 by 1 plus mod x by y. Okay? Okay, Lina?
Yes, ma'am.
So this is the formula. How we got this formula? Once you will be taking r plus 1th term is greater than rth term. Once you will be writing ncr of x to the power n minus r, y to the power r, then rth term you will be having like again in the same manner. And once you will be just simplifying it, you will end up getting this one, the yellow one. Here also you will end up getting this term, the yellow and minus 1. So we are saying rather than saying every time n plus 1 by 1 plus mod x by y, we are giving it a name. Let's say your name is m. Okay. Now we got the relation that r is lying in between m minus 1 to n. Okay. Is it clear?
Yes,
Now
ma'am.
how the question will be there. Let's solve the question so that you will be having the better understanding that how to apply the concept in the question. The largest term, or rather we will be saying numerically largest term in the expansion of 3 plus 2x to the power 50, where x is equals to 1 by 5 is option A, fifth, option B, eighth, option C, seventh, and option D, sixth. Okay, numerically largest term we have to find. For numerically largest term, now only we have seen the formula, that is m is equals to what we have seen, the yellow part, n plus 1 by 1 plus mod x by y. N plus 1 by 1 plus mod of x by y. This was the m. Okay, which we were having in the formula. Let's find m. So n is what? N is 50. Can you see? N means power. Can you see it, Lina?
Yes, ma'am.
N is 50. Now we are doing n plus 1 by 1 plus mod x by y. Mod of x is 3 and y is 2y. 2x. Getting it? Is it
Yes,
clear
ma'am.
so far? So we will be having 51 divided by 1 plus mod of 3 by 2x. X value is already given as a 1 by 5. Let's substitute it. So 2, 1 by 5. Okay. That is equals to 51 by 1 plus mod of 31 by, okay, it's not 31. It was 3 only. And 3 will get multiplied with 5 divided by 2. Is it clear so far?
Yes.
So let's simplify it. We will be having 15 over 2 over here. Okay, that means 51 by 15 by 2. 1 plus 15 by 2. If we will be simplifying it, what we will be getting? 2 in denominator 17 will be there, right? And in numerator 15 into 2,
Yes.
51 into 2 will be there, right? Is there any confusion in the calculation part?
No, ma'am.
Is there any confusion? So let's simplify it. Can you please simplify and tell me what will be the decimal value? Are you doing it?
Yes, ma'am.
Yeah, do it. 17 3 times 51. Even if we will not be getting in decimal, I can see over here. Can you see?
Yes, ma'am. It's 6.
It's 6. Okay. So we got 6 over here. M value we got 6. Now we know what we have to find first. See. The largest term in the expansion of this one, where x is this, is the largest term. Okay. So we know R must be lying in between m minus 1 to m. M is 6. So R 6. 6 minus 1, that is 5. R is lying in between 5 and 6, and the largest value of R from here is, yes Lena, the largest value of R from here is, it R is lying in between close interval 5 and 6. So the largest value of R is, can we say 6?
Yes, ma'am.
R can be 5 also, because equality sign is also there. R can be 6 also. So the largest value of R is 6, right? Getting
Yes,
it?
ma'am.
So our
Yes,
largest
ma'am.
value is 6. Got it? Let's summarize what we did. Numerically largest
Yes.
term. There is a formula that R will be lying in between m minus 1 to m. What is m? First we have to find m only. That is the main job. That first thing first we have to find m value. How we will be finding m value? We will be taking, we will be taking like we know m is n plus 1 by 1 plus mod of x by y. Accordingly, we will be finding m at first, and then we can go ahead and we can find the range of r. From there, easily we will be able to take out the largest value. Okay, got it?
Yes, ma'am.
Here it says find the term which has numerically, whenever it says the word numerically greatest coefficient, we have to use this formula. Greatest coefficient in the expansion of 3x minus 2 to the power 21. Okay. Here, first thing first, numerically greatest, once you will see, you have to find m. What is m? N plus 1 by, what was there? 1 plus mod of x by y, right?
Yes, ma'am.
N is 21 plus 1. Let's do it quickly. 1 plus modulus of x is 3x, y is minus 2. Is it clear so far?
Yes, ma'am.
Now find the term which has numerically greatest coefficient. This term is having the numerically greatest coefficient. So we will be having 21 plus 1, that is 22. 1 plus this, what is the value of x over here? That is not given. Okay, when the value of x is not given, we have to take the value of x as a 1. Okay? Okay, Lina? Because once
Yes,
you will
ma'am.
be expanding, suppose x plus 2 to the power 2. Once you will be expanding it, that is x square plus 2 times 4, 4x plus 4. Here the coefficient of x square is 1 only, right?
Yes,
So
ma'am.
whenever nothing is said about the coefficient, what is the value of x over there, we have to take it as a 1 only. Okay, and when the value of x is already given in the question, we have to substitute that for finding the value of m. So here x is not given, we will be taking 3 by 2 only as it is. Minus 2 is there, but since modulus is there, we will be taking it the plus value, right? So we will be having 22 by 1 plus 3 by 2, which is 22 into 2 by 5, right? 5 or what?
Yes, ma'am.
Yeah, 5. Is it okay? So we will be
Yes, ma'am.
having 44 by 5. Let's convert it in decimal. So 5, 8 times 40, 5, 8 times 40. We got m value as a 8. We know r is lying in between m minus 1 to m. R is what? R is the rth term. Okay, which term? So 8.8 minus 1 means 7.8 to 8, right? 0.8.
Yes, ma'am.
Now what the question says? Find the term. R is what? Term. Term can be one, first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. Term cannot be 8.8th term, 7.8th term, or 6.2th term, or 0.5th term. Term must be a whole number, right?
Yes, ma'am.
In between this, what whole number you are getting? If I am going to draw a number line, 7.8, okay, then the last one is 8.8. In between this, which whole number you will be getting? The whole number
8.
will be 8. So this R will be 8. Okay, getting?
Yes, ma'am.
Find the term, which term? Eighth term. Only you have to memorize m. That is m is equals to 1 plus n by 1 plus modulus of x by y. Getting it?
Yes, ma'am.
Now when the value of x is already given, easily you will be able to do it. When the value of x is already given, x to the power x is equals to 1 by 3, then the greatest term in the expansion of 1 plus 4x to the power 8. Can you please tell me quickly what we will be doing over here? Please tell me. M is equals to
1 plus n
by 1
divided
plus
uh, x by y.
x is
1 by 4x.
X value is 1 by 3. Let's substitute it over here. What we will be having, Lina? Can we write it as a 3 by 4?
Yes, ma'am.
Any confusion?
No, ma'am.
So we will be having 9 into 4 and 4 plus 3, 7. That means even if you are getting in decimal, all well. 36 by 7, 7 5 times 35, 1071 times 7. So 5.1 we are getting. So that is R is lying in between M minus 1 to M. That means 5.1 R and 5.1 minus 1 is 4.1. What is the value, possible value of R in between
5.
4.1 and 5.1? 5. So R is equals to 5. Fifth term. Okay. Is it clear?
Yes, ma'am.
Oh yeah, one thing I will be mentioning over here. Whatever we have found as a R value, whatever we have found over here as a R value, that is R. Okay. R we have got over here in the first question, the numerically largest term in the expansion of this. R value we got as a 6, right? But the
Yes, ma'am.
term will be R plus 1th term. That means term will be 7th term. R is 6. Term is 7th term. Getting it?
Yes, ma'am.
So if you are getting R as a 6, please mark it as a 7th term. If we are getting R over here as a 8, that means it's 9th term. Getting it, Lina? According to the general term condition. Okay?
Yes, ma'am.
If you are getting R as a 5 over here, so it will be TR plus 1th term, that means T of 6th term. Okay, here we will be marking 6th term. Getting it?
Yes, ma'am.
So whatever R value you are getting, that is the value of R. But the term will be R plus 1th term, and accordingly we will be marking the options. Got it? One
Yes,
last
ma'am.
concept, that is properties. Please note it down with me. Okay, of binomial coefficients. So there are few properties of binomial coefficient. Let me write the property. We will be discussing about it in a detail just after writing all the properties. So the first property says the sum, that is C0, C1, C2, Cn. The sum of all the coefficient will be 2 to the power n. Okay. The next The next property is C0 minus C1 plus C2 minus C3 plus dot 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 minus 1 to the power n Cn is equals to 0. Okay, are you writing it?
Yes, ma'am.
The third property says that C0 plus C2 plus C4 plus dot 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 is equals to 2 to the power n minus 1. Now only I am showing you how we are getting this. And the fourth property says C1 plus C3 plus C5 plus dot 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 is equals to 2 to the power n minus 1. Yeah, these are the four properties. Okay. Written, Lena?
Yes, ma'am.
So here for the first property, let's say we are having 1 plus x to the power n. And if we are doing the expansion of that, so the first term will be nc0, then nc1, then nc2, then nc. Let's write few of them. nc0, 1 to the power whatever, and then x to the power 0. Then nc1, 1 to the power n minus 1, and x to the power 1. Then nc2, okay, 1 to the power n minus 2, and x to the power 2. Like this it will keep on going, right, Lina?
Yes, ma'am.
Here if we will replace x by 1, we will be getting 1 plus 1 to the power n, right? And on the other side, if you will be replacing x by 1, like every x by 1, you can see the term will come out as a nc0. Uh, yeah, the term will come out as a nc0, nc1, nc2, nc3, nc4, nc5. That is equals to 2 to the power n, right?
Yes, ma'am.
That's what the theorem says. That if we are having C0, C1, C2, that means the coefficient. This C1, C2 means this is just NC0. This is just NC1. This is just NC2. This is just one of the way of writing it. That the first coefficient, second coefficient, third coefficient, fourth coefficient, last coefficient is equals to 2 to the power n. From where it came? Once we have replaced x by 1 in the expansion of 1 plus x to the power n. Okay, got it?
Yes, ma'am.
Similarly, and in the above expansion, if we will be replacing x by minus 1, we will end up getting 0, right? From there only this 0 came out. Are you able to connect with that?
Yes, ma'am.
Okay, let's move ahead. Now, once we will be adding equation 1 and equation, the property 1 and property 2, can you see we will end up getting property 3? Here we will be having
Yes,
2C0, then C1 gone, 2C2, then C3 gone, 2C4. So accordingly, we are having C0, C2, C4. And since every term is having 2, 2, 2, 2, that 2 we have shifted to other side, and that became 2 to the power n minus 1. Got it?
yes, ma'am.
Now, if we will be subtracting property 1 and 2, then we will end up getting property number 4. Again, just like the previous one. Once you will subtract it, all the negative one will get just added, and whatever was positive, since you are subtracting it, it will get cancelled. Okay, and you will be having this expression. Got it?
Yes, ma'am.
Let's do one question so that you will be able to understand the question also. So the question is 13C0 plus 13C1 plus 13C2 plus 13C3 is equals to, so NC0, NC1, NC2, NC3. We can see every term is there. So it is property number 1, which says 2 to the power n, right? Will be the
Yes, ma'am.
answer. Getting it?
Yes,
Now,
ma'am.
if the next question is there, that is 21C1 plus 21C2 plus 21C3 plus 21C20 is equals to what? So here we will see 1 is there, 2 is there, 3 is there, 20 is there, everything is there. It is property number 2, 3, 4, which one? So it is not following any pattern for 2, 3, 4. Only one thing we can notice here, that 21C0 is missing, and the last term, that is 21C21 is missing, right?
Yes, ma'am.
So we can say if 21C0 and 21C21 would have been there, then the expansion will give 2 to the power 21, right?
Yes, ma'am.
If this, since these two terms are missing, so from 2 to the power 21, we need to subtract 21C0 minus 21C21. Getting it?
Yes, ma'am.
And we know how to calculate 21C0. We also know how to calculate 21C21 also. This two we will be doing the calculation, and this 2 to the power 21 we will be writing as it is, and we will be looking for proper option. Okay? Are you getting it, Lena?
Yes, ma'am.
Okay. Now one last question. This you are going to do it, okay? If the I'm going to explain the concept and you will be doing it. Coefficients of second, third, and fourth term in the expansion of 1 plus x to the power 2n are in AP, then 2n square minus 9n plus 7 is equals to option A minus 1, 0, 1, 3 by 2. Since it says that the coefficient of second, third, and fourth term, you already know how to find the coefficient of any term. So if 1 plus 2x, 1 plus x to the power 2n is there, you have to find second, third, and fourth term. Will you be able to take it out?
Yes, ma'am.
Second term will be 2nc r plus 1
1.
is 1. Then 1 to the power 2n minus 1 and x to the power 1, right?
Yes, ma'am.
Next one will be 2
2n
c
C2 1 to n minus 2 x2 3 1 to n minus 3 x3.
Now here it says the coefficient of second, third, fourth term are in AP. Coefficients are in AP. Okay. Coefficient means 1 to the power anything is 1. 1 to the power anything is 1. 1 to the power anything is 1. Coefficient means this, this. Obviously including 1, but that is only giving us 1. That's why, like, even if we will multiply, we will be having 2 and C1 only. So coefficients are 2 and C1, 2 and C2, 2 and C3. These are the coefficients, right?
Yes, ma'am.
It's in AP. What's the formula? Like, what's the condition for AP?
They have to have equal difference.
Yeah, equal difference. So we can write it as 2n C2 minus 2n C1 is equals to 2n C3 minus 2n C2. Can we?
Yes, ma'am.
Here also 2n C2, here also 2n C2. Let's write both of them together. So we will be having 2 times twice n C2 is equals to twice n C3 plus twice n C1, right? This looks like
Yes, ma'am.
2b is equals to a plus c. That is also one of the expression for AP, right?
Yes, ma'am.
Now we just need to solve it. Okay, we just have to solve it to get the value of, let's solve it quickly. So 2 is there, 2n factorial by 2n minus 2 factorial. 2 factorial is equals to 2n factorial by 2n minus 3 factorial, 3 factorial plus 2n factorial. Okay, even if we will do 2n minus 1, and it will be only 2n, right? Right, Lena?
Yes.
2n minus 1 factorial into 1 factorial. So basically we will be having 2 multiplied with, can we cancel out all the 2n's? Better to simplify it. Okay, don't cancel it out. So here in numerator we will be having 2n minus 1, right? And 2n minus 2 will go with the denominator. Are you getting it?
Yes, ma'am.
So by 2 we are having also. By 2 is there. Is equals to 2n minus 1, 2n minus 2. And then 2n minus 3 factorial will come, which will cancel out the denominators one. Are you getting it?
Yes, ma'am.
Plus here we will be having only 2n. Let's see what else can be done. 2n, 2n minus 1. Let's take it out 2n common. 2n minus 1, 2n minus 2 over, okay, 2, 3 times 6. Okay, don't cancel it. Let's take out 2n common and let's see what else are we getting. Plus 1. 2n, 2n gone. Got it?
Yes,
Got
ma'am.
it, Lena? Let's simplify and let's check what exactly are we getting. What do we have to find? We have to find the value of 2n square minus 9n plus 7. Okay. We are having 2n minus 1 over here. We are having, if we will multiply, we will be having 4n square. Then we will be having minus 4n. We will be having minus 2n. And then we will be having plus 2 plus 6 divided by 6. Is it clear?
Yes, ma'am.
So we will be having 6. Let's crisscross multiply. So 12n minus 6 is equals to 4n square minus 6n plus 8. 4n square minus 6n minus 12n plus 8 plus 6 is equals to 0. 4n square minus 18n 14 is equals to 0. A quadratic form we ended up getting. What we needed to find here? We needed to find 2n square minus 9n plus 7. Is it possible to take out anything common from here? So can we say 2n square minus 9n plus 7 is equals to 0?
Yes, ma'am.
So here we will be marking option 0. Is it okay?
Yes, ma'am.
So what we did, if the coefficient of second, third, fourth term are in the expansion of this one are in AP. So we have found the coefficient easily, second, third, fourth term by finding from